In this video, we're going to start focusing on interval estimates called confidence intervals. And we're going to talk about several over the course of the rest of this course. We're going to start with the two most common, but it turns out that all confidence intervals that we're using this semester have the same basic structure. We know from last time that the basic structure of a confidence interval is centered around the point estimate. Meaning the sample statistic that best corroborates with the parameter we're trying to estimate. If I'm estimating a mean, I want to use the sample mean. If I'm estimating a proportion, I want to use a sample proportion. And then around that point estimate, we're going to build an interval by adding and subtracting a margin of error. Your book is going to call that the error bound, or EB. Most of the textbooks that I've used before call this ME for margin of error. I don't care which one you use either. I will know what you're talking about. But you will see EB in your textbook. And that margin of error can then be broken down further. So a confidence interval is a point estimate, the center of our interval, plus or minus a critical value, which has to do with how certain we want to be that our interval captures the population parameter, times the standard error of the parameter we're estimating. And remember that standard error is the standard deviation of a sampling distribution. This has to do with the spread of data. And those were the two things we mentioned in our last video. So the point estimate is the sample statistic that best corresponds to the parameter, and it may be given to you in the problem more often than not, though sometimes you'll be given a list of raw data and asked to calculate it like we did in our last video. The critical value is based on how confident we want to be, and why did I just lose my train of thought? Sorry about that. And how confident we want to be is called the confidence level. So our critical value is based on our confidence level, and that's usually given to you as a percentage in the problem. The most common values are 90, 95%, 99%. If you are not given a confidence level in the problem, you should assume 95. That's the default value for our calculations in Intro to Stats. The standard error is the standard deviation of the sampling distribution constructed from our sample data. The formula for the standard error is going to vary depending on what parameter we're estimating. So we'll use a different standard error for means than we do for proportions, than we do for standard deviations. We're also going to use different critical values depending on what we're estimating. The three confidence intervals that we're going to be focusing on in this week are confidence intervals for a mean when we know the population standard deviation, confidence intervals for a mean when we do not know the population standard deviation, and for proportions. And remember, proportions are percentages We saw them when we talked about the binomial distribution. 62% of voters voted yes on a most recent proposition, right? 83% of students at Rancho San Juan are involved in extracurricular activities. It's a percentage of people that either fall in a yes category or a no category. Each of these has their own distribution and their own standard error. For means, our distribution is going to be the standard normal distribution when we know our standard deviation for the population, also called the Z distribution. And we saw the standard error for this, or the standard deviation for a sampling distribution, last week when we learned about the central limit theorem when we looked at sampling distributions. We know that the standard deviation of a sampling distribution is the standard deviation of the population divided by the square root of the sample size. For means, when we don't know what the population standard deviation is, when we're unsure how spread out that data is about the mean, we use something called a student t distribution. Sometimes just the t distribution. The t distribution is very similar to the standard normal curve, except that he tends to be wider and he depends on your sample size. The smaller the sample size, the wider the curve will be. And we're going to take a closer look at the student t distribution when we get to the video on means without a sigma. For the standard error, we're estimating a mean, so the format of that equation for standard error is the same, but I don't know sigma, so I'm going to estimate it with the next best thing, which is the sample standard deviation. So same structure, but now it's sample standard deviation divided by square root of n. For proportions, we are estimating a discrete binomial curve with our standard normal curve. So proportions, we go back to our standard normal, or z curve. And the structure of their standard error is the same. We're going to take a look at a shortcut or a reduction of what that formula is. And it ends up being p prime times q prime over n. And that's going to look like nonsense right now because I haven't talked about it. We will get into that when we get to the proportions video. You'll notice there is a square root of n in the bottom of all those fractions. So we're seeing the same behavior with standard error that we saw in week 3. Reminders that it's the distribution that is determining our critical value. And then the standard error is the second piece of our margin of error. Our margin of error is critical value times standard error, and critical values coming from that distribution that we're using for our sampling distribution. All right, there were a lot of big ideas in this video. If you have any questions on what you saw, feel free to email or drop by office hours. Over the next couple of videos, we're going to take a look at specifically how each of these 3 confidence intervals work. And I'll see you in the next video.